Exercise 1.82 Superposition of charges. In the figure, the net electrostatic force on charge QA is 0. If QA equals plus 1 nanocoulomb, determine the magnitude of Q0. This is our picture. We have 4 charges here. Q0 located at the origin, QA, another positive charge. Q0 and QA are positive charges. QA has coordinates 2a, 2a. And we have 2 negative charges as well, Q1 and Q2. Q1 is located on y-axis at a distance a. Q2 is located on the x-axis at a distance a. So this is this distance is a. This distance is also a. And because this has coordinates 2a, 2a, this total distance is 2a. This total distance is also 2a. That's why this side is 2a and this side is also 2a. It's the same. So I'm going to draw a line here connecting, use a different color, connecting Q0 and QA, the 2 positive charges. So this is a square. Draw it separately. This side to A, this side to A, this side to A, this side to A. And this line connecting Q0 and QA is the diagonal of this square. So that makes this angle 45 degrees. This angle 45 degrees. So this angle is 45 degrees. This angle is also 45 degrees. Because it's a square. If you still have confusion, if you want to solve it, then let's consider this triangle here. This triangle. Let's consider this triangle. Draw it. Yeah. This side is 2a. This side is also 2a. We are finding this angle theta. So we have opposite side and adjacent side. So it's a tan theta. Tan theta equals opposite over adjacent. Tan theta equals 2a over 2a, which is 1. So tan theta equals 1. Theta equals tan inverse 1, which is 45 degrees. Yeah, you don't really need to solve it because it's a square. If you draw a diagonal, it will divide this 90 degrees angle exactly into 2 halves. So 45 degrees each. 45, 45. Yeah. Going to delete this. Yeah. Now I'm going to draw a line connecting Q1 and QA. So use a different color. Q1 and QA. Yeah. I'm going to find this distance. Okay, let's call this. This is connecting charge A and charge 0, right? So I'm going to call it RA0. This is connecting charge A and charge 1. So I'm going to call it RA1. Okay, let's find RA1. So let's consider this triangle here. This triangle. We'll draw it separately. Okay, this triangle. This one. So this side is A. This side is hypotenuse is not given. This side is 2A. I'm going to find this angle. This angle here. I'm going to call it alpha. Okay, so this is my angle alpha. Okay, it's the same angle because we are considering this triangle, right? This triangle. So I'm going to find alpha. Again, in this triangle we have opposite side and adjacent side. So I'm going to use tan. So tan theta equals opposite side over adjacent side. So tan theta equals opposite is A, adjacent is 2A. Cancel it out. Cancel. Tan theta equals 1 by 2. Theta equals tan inverse 1 by 2. Use your calculator to solve this. You'll get theta equals 26.56 degrees. 26.56 degrees. All right. So this total angle is 45 degrees and this angle is 26.56 degrees. So I need to find this angle. This is my main angle. I'm going to call it theta. How do you find theta? So theta equals this total angle is 45 degrees and this angle is 26.56 degrees. So how do you find this angle then? The total angle 45 minus this angle 26.56. So the total angle, which is 45 degrees, minus this small angle alpha, which is 26.56 degrees. So you'll get 18.44 degrees. That is theta. Theta is 18.44 degrees. 18.44 degrees. That's this angle. Okay. I'm going to do the same thing for charge Q2 as well. Both of them are same charges, right? Minus 1 nanocoulomb, minus 1 nanocoulomb. And they're located exactly the same distance from the origin. Okay, so yeah, if I draw a line here, I'm going to call it the distance between charge A and charge 2. So I'm going to call it RA2. RA2, distance between charge A and charge 2. Again, this whole angle is 45 degrees. They are same charges and located at the same distance from the origin. So we have a symmetry here. This angle is alpha, which is 26.56 degrees, and this angle is theta. This angle is theta, which is same as this one, 18.44 degrees. Okay, so we found all the angles. Okay, now we are going to find RA1, RA0, and RA2. Again, we will find RA0 and RA1. RA1 should be equal to RA2 because they are same charges located exactly at the same distance from the origin. So let's find RA0. RA0. So this is RA0, right? So to find RA0, I'm going to consider this triangle, this big triangle, right triangle. Okay, yeah, to draw it here. This is that triangle. This side is A plus A, 2A. This side is also 2A. Base is 2A, height is 2A. We know this angle, which is 45 degrees. And we are going to find the hypotenuse, right? Which is RA0. Yeah, RA0 is the hypotenuse. So it's a right triangle, so you can apply Pythagorean theorem here. Square root of 2A the whole square plus 2A the whole square. So you'll get square root of 4A square plus 4A square, which is equal to square root of 8a square. Yeah, that's RA0. So this is square root of 8a square. Square root of 8a square. Yeah. I'm going to delete this. Now I'm going to find RA1. Okay. I'm going to consider this triangle now, this small triangle. Okay, I'll draw it here. Small triangle. It's a right triangle. This side is 2a, the base is 2a, this is 2a, and this side is a. This side is a. And we are going to find RA1, which is the hypotenuse. Hypotenuse is always opposite to 90-degree angle. That's why RA1 is the hypotenuse. Okay, so we're going to find RA1, which is the hypotenuse of this right triangle. Again, we can apply Pythagorean theorem here. RA1 equals square root of 2a the whole square plus this side is a square. So square root of 4a square plus a square, that is equal to 5a square. Yeah, we found RA0 and RA1. RA1 should be equal to RA2. So RA2 will be the same. Square root of 5a square. If you want to solve it, you can do it. Again, you can consider this right triangle. This side is a, this side is 2a, so you'll end up with the same answer. So RA1 equals square root of 5a square. Again, RA2 will be the same, square root of 5a square. So we found all the angles, especially this angle, theta, 18.44 degrees. We'll use this later. Then RA1, RA0, and RA2. We found everything. Now let's apply superposition principle. One thing mentioned in the question is the net electrostatic force on charge QA is 0. So net force on QA equals 0. That's given. Net electrostatic force on charge A equals 0. So I'm going to write the equation. Net electrostatic force on charge A is equal to force by charge Q0 on charge A. Force by charge Q0 on charge A plus force by charge Q1 on charge QA. Force by charge 1 on charge A plus force by charge 2 on charge A. Charge 2 on charge A. Yeah. And net force on A equals 0. So we can substitute this to 0. 0 equals F0 to A plus F1 to A plus F2 to A. Yeah, this is the equation we are going to use. I'm going to call this equation number 1. Again, these are all vectors. We are dealing with two-dimensional problem, so it's going to be vector addition. We can't directly add them, okay? But I'm going to find the magnitudes of all these forces. Finding magnitudes of forces. Okay, the first one, F0 to A. F0 to A. F0 to A. So this one, right? The interaction between Q0 and QA. Interaction between Q0 and QA. Both of them are positive charges. Q0 is unknown. QA is 1 nanocoulomb. Sorry. Yeah. So we're going to find the magnitude of that force between Q0 and QA. So we can apply Coulomb's law. What is Coulomb's law? Electrostatic force equals K between charge 1 and charge 2 is Q1, Q2 over the distance between them squared. That's the electrostatic force between two charges. In our problem, these are the two charges, Q0 and QA. So force between them will be equal to K, Coulomb's constant, times Q0. The next charge is QA divided by distance between charge 0 and charge A. Distance between charge 0 and charge A is RA0. The whole squared. Next force is force by charge 1 on charge A. So we're going to focus here. These two charges, Q1 and QA, the interaction between them. So we're going to find the force applied on charge A by charge 1. So force by charge 1 on charge A. That is K, charge number 1, Q1, absolute values. I ignore the negative sign, and charge A, which is QA, divided by distance between 1 and A, the whole squared. Now the third one, F2 to A, force by charge 2 on charge A. K, first charge is Q2, again absolute values, QA over distance between charge 2 and charge A, the whole square. I'm not substituting the values now. We'll do it later. Yeah. Okay. Now let's find the directions. Okay. We have three vectors. We're going to deal with the directions now. Okay. So I'll draw this picture separately. Okay. Smaller picture. So I have Q0 here. This is Q0. It's a positive charge. I have QA here, another positive charge, a negative charge here, and a negative charge here. Yeah, that looks good. Yeah. Okay, this is a negative charge Q1. This is another negative charge Q2. Okay, so we are going to find the total force on QA. Okay, it is given the net force is 0, but we are going to find the directions of the net force on QA. I'll draw the directions. So Q1, let's start with Q1. Q1, being negatively charged, will try to attract QA, right? Q1 is negatively charged, QA is positively charged, so they are opposite charges. So there is a force of attraction between them, or Q1 will try to attract QA to its side. Again, QA is also attracting Q1, but we are finding the total force on QA. That's why the direction is towards Q1. Q1 attracts QA towards its side. And what about Q2? Again, Q2 is another negative charge, so Q2 will pull QA towards its side. Yeah. So this is force by 1 on charge A, and this is force by charge 2 on charge A. Yeah. So these are the directions of these forces. We already calculated the magnitudes. Now we are finding the directions. And what about Q0? Q0 is a positive charge, right? And QA is another positive charge. So Q0 will try to push it away from it. Okay. So the direction of the force will be like this. to try to push QA away from it, right? So this is force by charge 0 on charge A, F0 to A. Now, okay, this is my x-axis, right? X-axis. This is my y-axis. The problem here is none of the forces are on any of the axes, right? This is F0 to A, this is FQ to A, FQ to A, and this is F1 to A. So what I'm going to do here is I'm going to rotate it a bit counterclockwise. Okay, I'm going to rotate the whole thing a bit counterclockwise so that F0 to A aligns with the x-axis. Okay, so I'm rotating it counterclockwise. Yeah, now F0 to A is on x-axis. I'll draw the axis. Yeah, F0 to A is on positive x-axis. Now this angle is theta and this angle is also theta. We already found theta, 18.44 degrees. Let's go back to this picture. This is the direction of F1 to A and this is the direction of F2 to A. So this angle is 18.44 degrees. This angle is also 18.44 degrees. So it's the same angle. This one, theta, 18.44 degrees. Same thing, just rotated it a bit counterclockwise. Didn't make any changes in the angle, so it will remain the same, 18.44 degrees. Okay, now what I'm going to do here is I'm going to find the components of F2 to A and F1 to A. First of all, I'm going to draw the components. Okay, so this is the x component of F1 to A, F1 to A, x component, and this is the y component, 1 to A, y component. Yeah. Now, how do you draw the components for F2 to A? This is the x component along the x-axis. F2 to A, x component. This is the y component along the y-axis. F2 to A, y. We don't need to find the components for F0 to A because it's already on x-axis. It has no y component, it has only x component. Yeah. So how do you find F2 to AX? F2 to A x component. In this picture, you can see theta is touching the x component. If theta is touching a component, that component is the main vector, which is F2 to A cosine theta. So what about F2 to AY then? Y component is not touching theta, right? So that is F2 to A sine theta. Okay, let's find F1 to AX. F1 to A x is equal to okay, there's one more thing. This is going to the left, so this is negative. F2 to A cos theta is negative. This is positive. What about F1 to AX? F1 to AX is again theta is touching the x component. So it will be F1 to A cosine theta with a negative sign. What will be F1 to A y component? F1 to A sine theta with a negative sign. The y components will get cancelled out because these are the same charges, right? Q2 and Q1, -1 nanocoulomb each, and they are opposite in direction as well, so they will get cancelled out. Let's find the net force on x-axis. net force on x-axis. How many forces are there on x-axis? 3. F2 to AX, F1 to AX, and F0 to A. So I'm going to write the general equation for this. Net force equals, there are 3 forces, so F1 plus F2 plus F3. So this is the first force, F0 to A. It's going to the right, so plus F net equals F0 to A plus what is F2? The second force, F1 to AX. F1 to AX plus F2 to AX. Net force on A equals 0, so F net is 0. F0 to A. And what is F1 to AX? F1 to AX is minus F1 to A cos theta minus F1 to A cosine theta. What is F2 to AX? F2 to AX is minus F2 to A cos theta minus F2 to A cos theta. Yeah. So rearrange it. F0 to A. Taking this to the left side, it will be minus. You can cancel out all the minus signs. So F0 to A equals F1 to A cos theta plus F2 to A cos theta. Okay, let's substitute the values now. F0 to A. We found 0 to A. K Q0 QA by RA0 square. K Q0 QA over RA0 square equals F1 to A, K Q1 QA over distance between 1 and A, the whole square, times cosine theta plus K Q2 QA over RA2, the whole square, cos theta. Okay, K Q0 QA over, what is RA0? We found RA0. RA0 is root 8A square. So root 8A square, root 8A square, the whole square equals, so we have two terms here and we have K and QA common in both the terms. So I'm taking K and QA outside the bracket, K QA. If you remove K and QA from the first term, you are left with Q1 cos theta over RA1 is root 5A square. Root 5A square, the whole square. We have another square here, that's why, yeah. Plus, again, K and QA are outside the bracket, so Q2 cos theta over RA2 is same as RA1, root 5A square, root 5A square, the whole square. Okay, let's cancel out a few things from here. You have K and QA here, cancel it out. Square and the square root can be cancelled as well, so that's gone. So on the left side we have Q0, here as well we have square and square root. Q0 over 8A square equals q1 cos theta over 5a square plus q2 cos theta over 5a square. We need to find q0, so I'm taking 8a square to the right side. q0 equals 8a square. Taking 8a square to the top. So 8a square times, so we have 1 by 5a square common in both the terms, right? Take it outside. 5a square. q1 cos theta plus q2 cos theta. A square and a square can be cancelled. Yeah, now let's substitute the values. 8 by 5 times q1 is minus 1 nanocoulomb, again absolute values. So 1 times 10 to the power minus 9 times cosine 18.44 plus q2 is the same, 1 times 10 to the power minus 9 times cos 18.44. .04 times 10 to the power of minus 9 coulomb. 10 to the power minus 9 is nano, so it's 3.04 nanocoulomb, approximately 3 nanocoulomb.